reachable symbols or the useful symbols. Okay, generating in the sense each and every non-term should have productions. And then reachable in the sense each and every symbol should be reachable from the start symbol. Okay, so here you can see we have already dealt with this example, right? So here you can see there are three non-terminals, S, A, and B. Here, if you talk of the non-generating symbol, yes, B is not having any productions, right? So B is a generating symbol. So what we have to do, we have to eliminate all the productions which is having B, which includes B. So here I'm having a production which includes B. So this production needs to be removed. Okay. So at the end I'll be having this. So here you can see I'm having two non-terminals S and A where S is the start symbol. Can I reach this non-terminal from S? No, it is not reachable. Right. So this will be also eliminated. So the final is going to be S derives A. Okay, hope it is clear for you all. Right. Shall we proceed further?
Yes, ma'am.
So now we are going to proceed. Yes, ma'am. Thank you. So yes. So now we are going to proceed with eliminating epsilon production. Okay, epsilon production or null production, empty productions. That's it, right? So here we can start with an example. S derives AB. Okay, so here, which is a null production here? Empty productions. Which are the empty productions here?
A and B.
Yes. So when you see the grammar, or you can say that A and B are having epsilon production. So A and B are nullable. So here A derives epsilon and B derives epsilon. So A is having the possibility of being null. Okay, so A is nullable as well as B is nullable. So here you can see S derives AB, right? So here A is nullable, B is nullable. Here S derives AB. So what is the possibility? So if A is epsilon, B is epsilon, what is the possibility? S is also epsilon, right? So here, yes, A and B are nullable. Okay, all these three are nullable. So let me repeat. So by seeing the production, we can directly say that A and B are nullable because they are having epsilon productions. When I proceed with the reduction, so here you can see A is nullable, B is nullable. So if both are having epsilon, so what happens? S is also nullable. So I have to proceed with eliminating epsilon production with all. Okay. So here, please make a note. Whenever I'm going to proceed with the simplification, the meaning of the grammar should be the same. Okay. So here, let us start with eliminating the epsilon production in S. Okay, S derives AB. So now I'm going to eliminate the epsilon production. Here, please make a note. Whenever we are proceeding with eliminating or simplification, we have to retain the meaning. Okay, so here you can see what is the possibility here. A is having the possibility of being epsilon. If A is epsilon, what I will have? I will have one of B. So here again, what is the possibility? There is a possibility of B being epsilon. So what I will have? A I will be having. Okay. So S derives AB or A or B. So this is the possibility. Okay. So here again, A derives A or epsilon. So here I have to proceed with eliminating epsilon. So here, what is the possibility? I can have this A as epsilon. So in that case, I'll be having A. I can have this A as epsilon. In that case, I'll be having A. Right? And what is the other possibility? I can have both the A's as epsilon. So in that case, I'll be having B. Okay. So hope you can try with this one. So B derives. So can you all try with this? So here B, B, B. So here again, I have to eliminate epsilon. So what will be the Yes. So if this
on
B is epsilon, I will be having B. If this B is epsilon, I will be having BB. And then if both the B's are epsilon, I will be having
false.
only B. Yes, good. So this is how we will be eliminating the epsilon production. Hope it is clear to you all, right? Shall we proceed?
Ma'am,
Yes,
but
ma'am.
like in the second case, if the first case is both A and B are epsilon, then
Mm-hmm.
I didn't get the S1. Like if what if
Here,
both A and B are epsilon?
yes, that's what we are going to eliminating the epsilon production. Okay. So we are eliminating the epsilon production. Okay, so here if A and B are epsilon, it is going to be empty, right? So we are going to eliminate the epsilon. That's it.
Okay.
Okay. Okay. So here we can start with, yes. So next is eliminating of unit production. Eliminating unit production. So what is unit production? So please make a note. Unit productions of the form A derives B. Okay, so what is unit production? So productions of the form A derives B is called as unit production, where A and B are non-terminals. Okay, so A and B are non-terminals. So productions of the form A derives B is called as unit production, where A and B are non-terminals. Okay, we can start with an example. Okay, so here which are the unit productions now?
C derives D, D derives D,
C derives D,
D, D derives D,
D derives C, that's it.
and
What about this
E
one?
derives
B derives C.
C also.
Yes. So all these three are the unit productions. That's what we have seen. So productions of the form A derives B is called as a unit production, where A and B are the non-terminal. So here you can see B derives C, C derives D, D derives E are the unit productions. Okay, we have to eliminate these unit productions. So how we are going to eliminate it? So here you can see B derives C. So here B is dependent on this particular production, and D is so here this production is dependent on this particular production, and this production is dependent on this particular production. Yes, isn't it? So here B derives C, C derives D, D derives E, and E derives A. So what should I do now? First, I have to proceed with. So here D should be. So please make a note over here. So let me have all these productions, right? So here I have to eliminate. First, I have to eliminate this. Only if I eliminate this, I can proceed with eliminating here and here. Okay. So in order to eliminate this, what should I do? So here unit production gives unnecessary transition. Okay. So D derives E, E derives E. So what can I do? I can have the productions of E over here. Okay. So D derives E. D derives E. So now this is reduced. So this is removed. Okay, this unit production is eliminated. So now what is the next one? So C derives D. So what is C derives D? So what is D? D derives A. So here C derives D, which is nothing but E. Okay, so this unit production is also removed. Next step is B derives C. So what is C? C is nothing but E. Okay, so B derives E. So this is also removed. So at the end, what about the productions we'll be having? S derives AB, A derives A, B derives C or B, right? So here B derives C. So what is, so here instead of B derives C, we are having A, right? A or B. Next production is C derives A, D derives A, E derives A. C derives A, D derives A, E derives A. Isn't it? Yes. So here what you can infer? After eliminating unit production, so what is my grammar simplified now?
No, ma'am.
Hmm.
C, D, E are non-reachable states.
Yes. So here you can see C, D, E are non-reachable, right? So this can be removed. So the final grammar will be this. Okay. S derives EB, A derives A, B derives ARB. So please wait. It will be clear for you when we see one more example. Okay. So for unit reduction, we can see one more example. S derives A or B. So please make a note over here. So this is why you have to check with the what is that formal definition of grammar. It is not mandatory that first symbol comes in the grammar is the start symbol. So here you can see E is the start symbol. Okay. So E derives a T or E star T, T derives F or F, T star F, F derives S or within bracket S and S derives these, right? Here we have to eliminate the unit production. So what about the unit productions here?
T derives F, F derives S,
Hmm. Then
and
please see here A derives B. The productions of the form A derives B are called as unit production where A and B are the non-terminals. So which are the productions that is taking this particular form?
so T derives F,
Okay, T derives F.
F derives S, and
What about this one?
but
Right?
ma'am, that's a start symbol.
Then what
Okay,
is
yeah, E
uh,
derives, E
yes,
derives
please make a
E.
note over here. You need not worry whether it is start symbol or not. So the productions of this form is called as the unit production. Okay. E derives T. Okay. So what should I do? I have to proceed with eliminating this unit production. So here you can see if I have to eliminate this, I have to proceed. So here you can see E derives T, T derives S, and F derives S. Okay. So here F derives S. So if I want to eliminate F derives S, what should I do? I should take the productions of S and I should keep it here. Right? Do you all agree with that?
Yes, ma'am.
This yes. And F derives Okay, or in bracket E. Okay, I have to eliminate this one, right? So I have eliminated. In order to eliminate it, I am taking all the productions of here of F and I am placing it here. So next, what is the thing? F derives F or T derives F. Here you can see. So this is we have eliminated. Next we have to move on here. So T derives F. So what should we do? We have to proceed with eliminating. So what should I do? So if I want to eliminate the productions of, if I want to eliminate this unit production, what should I do? I have to place the productions of F here. Okay, all the productions of F should be placed here. So here, star F. Okay, then next. So this we have eliminated. And sorry. So here next we have to eliminate this one. So what should I do? For all the productions of T should be placed here. So E derives. Are you clear with this? That clear?
Yes, ma'am.
Yes. So should I remove all the rest of the productions here? Here in the previous example, we have removed these things, right? So why we have removed? Because C, D, E are not reachable from the start symbol. Whereas here you can see, so here this is E is the start symbol, from S is reachable, from yes, from E I can reach T, F, everything, right? All the productions are reachable from the, sorry, all the non-terminals are reachable from yes. So this is the final uh, grammar after eliminating the unit reductions. This is going to be, this is what we are going to proceed in the simplification of context-free grammar. Okay. Now we can deal with one example and then we can proceed with converting that grammar to Chomsky normal form. Okay. So here we can start with. Okay, so conversion to Chomsky normal form. So please, before that, please do make a note of it. Safe ordering of for simplification of context, right? Because we are dealing with three different steps, right? So that is user symbol elimination, unit production elimination, epsilon production elimination, right? In order to deal with this, these steps cannot be done interchangeably because what happens is if I proceed with the here you can see, yes. So here you can see, initially there was no, is there any user symbol in this grammar? Can you see any user symbol here? Any user symbol here? Why, what happened? Are you clear with this? So please see here. So from S, I can reach A and I can reach B. So please see here. What are the non-terminals here? S, A, B, C, D are the non-terminals. From S, I can directly reach A and B. Okay. So from B, I can reach C. From C, I can reach D. From D, I can reach E. Okay, sorry, I'm clear with this. From A, S, I can reach A and B. So from B, I can reach C. In the sense, I can reach C from S. So similarly, from C, I can reach D. So in the sense, D, I can reach from S. From D, I can reach E. In the sense, E is reachable from S. Do you all agree with this? Why, what
Yes,
happened
ma'am.
now? Yes. Okay, so but after eliminating the unit production, what happens? These three symbols are identified as user symbols, right? So because they are not reachable. Okay, so if I'm proceeding with eliminating the user symbol and then proceeding with unit production, what happens? I have to do the steps again and again. So in order to avoid that, we have to proceed doing the simplification in a safe order, following a safe order. What is the safe order of simplification? First, I have to eliminate the epsilon production. Okay, we have to eliminate the epsilon production. Then we have to eliminate the unit production. Okay, and then comes the useless symbols. Then comes the useless symbols. So this is the safe order for simplification. Okay. Okay, so we can start with an example. So here we are going to take an example for converting the grammar to Chomsky normal form. Conversion to Chomsky normal form. Already we have seen what is Chomsky normal form. What is Chomsky normal form? All the productions in CNF will have only productions of this format. That is A derived species. That is two non-terminals of only one terminal symbols. Okay. Okay, so let us take an example. Okay, so here, uh, yes, we can start with. So what is the first step? So we have to proceed with the simplification of this particular grammar. For simplification, so already we have seen what is the safe order for simplification. So first we have to eliminate the epsilon production. So what are the epsilon productions? So first we have to eliminate epsilon production. Okay, so in order to eliminate the epsilon fraction, so here you can see what are the epsilon fraction. P derives epsilon, U derives epsilon, W derives epsilon. Okay, so from the grammar you can say that T, U, W are nullable. Okay, T, U, W are nullable. Okay, so when you proceed with reduction, you can see V derives W. Okay, V derives W. So here W is nullable. So what happens? V is also nullable. Okay, so please do see here. T, U, W are nullable. Okay, T, U, W are nullable. So then if you see this production, so here you can see B derives W, right? So because of this, you can conclude that B is nullable. Okay, B is nullable. So and the next production is, here you can see S derives V, right? So V is nullable. S derives V. So S is also nullable. S is also nullable. Why? Because we are having a production S derives V. Okay? Because we are having a production S derives V. So we have to eliminate all the nullable productions. Okay? Here even you can see TU or B. So what is TU? So TU is already nullable, right? So TU is already nullable. So because because of both the productions, S is nullable. Okay, S derives B or TU, whatever it is. So for both the cases, it is nullable, right? We have to eliminate nullable first. Right? So here we can start with S derives TU or T. Okay, S derives TU or T. So here you can see there is a possibility of T being nullable. If T is nullable, we will be having U. If U is nullable, we will be having T. Right? I'll be having TU as a whole. Right? TU I'll be having. If this U is nullable, I'll be having T. If this T is nullable, I'll be having. And next comes, okay. So this is with respect to the first one. And next comes S derives A, T, B or epsilon. Right, sorry. T derives. T derives A, T, B or epsilon. So I have to eliminate that. So what is the possibility I can have? T being nullable, right? So there is possibility that T is epsilon. So what I'll be having? If T is nullable, what I'll be having?
AB?
A, B. Yes, good. Okay. So the next is U derives CU or epsilon, right? CU or epsilon. So what is the thing? So if I eliminate, if I want to eliminate nullable, so what is the possibility? If U is epsilon, what I'll be having? I'll be having only C, right? And then B derives A, B, C or W. A, B, C or W. So here you can see B is nullable. Already we have discussed, right? B is nullable. So A, B, C or W. So if B is nullable, what I'll be having? I'll be having only A, C. Next is W. That's it. And next comes W derives BW or epsilon. BW or epsilon. So what is the possibility? If W is nullable, I'll be having B. Okay. So this is how we'll be eliminating the epsilon production. Hope it is clear to you all. Shall we proceed further?
Yes, ma'am.
Okay. Yes. Next, we can eliminate the unit production. Eliminate unit production. So here you can see. So what are the unit productions here? What are the unit productions present here?
S derives T, S derives U,
Yes. Good.
S
S
derives T,
derives T U
U, B,
then
B derives W.
yes. Yes, right. So what should we do? So we have to, so if I want to eliminate S derives T, what should I do? All the fractions of T should be placed here. If I have to eliminate S derives U, what should I do? I have to place all the productions of U here. If I want to eliminate S derives V, what should I do? All the productions of V should be placed here, right? Here, what happens? V derives W is there. So what should I do? First, I have to eliminate this one, right? So here, if I want to eliminate V derives W, what should I do? I have to proceed with productions of W should be placed here, right? Okay, so let us start with S derives TU or T, right? S derives TU or T. So what should I do? Productions of T. A, T, B or AB, right? And similarly, S derives U. So what should I do? Productions of U, U or C. And if I have to eliminate S derives B, what should I do? Productions of B, A, B, C or AC. Here I am having W, right? So that should also be eliminated. So what should I do? Productions of W should be placed here. W or B. Okay. So the rest is T derives the same thing. T derives. Needs to be eliminated, right? B derives W needs to be eliminated, which is nothing but BW or B. Maria, clear with this? Any doubts?
No, ma'am.
Yes, good. Yes, next we can proceed with eliminating the useless production. So please do check. So which are the eliminating useless production? So which are the useless productions here?
None.
Yes. What about others now? So here you can see all symbols. So what are the non-terminals here? S, T, U, V, W are the non-terminals. All the non-terminals are having production, right? And another thing, non-reachable. So here you can see, yes, all the non-terminals are reachable from S, right? So T is reachable from S, U is reachable from S, and S, B is also reachable from S, and then W. So W is also reachable from S, right? All the non-terminals are reachable from the start symbol. So here you can see no useless symbols, no useless production. Okay. Now we can proceed with converting this grammar to Chomsky norm. Converting this grammar to Chomsky normal form. So this is the simplified grammar. So this simplified grammar should be converted to Chomsky normal form. So what is Chomsky normal form? So here in Chomsky normal form, all the productions should be having either two non-terminals in the side or only one terminal in the side. Okay, so when you check here, you can see, yes, this is in Chomsky, this is in Chomsky, this is in Chomsky, this in Chomsky, this is in Chomsky, right? So please make a note. The production should take the form A derives BC or A derives A. So I can either have two non-terminals this side or only one terminal this side. Okay, so this is Chomsky normal form. So here it is very simple. After simplification, converting the grammar, simplified grammar to Chomsky normal form is very simple. Just we are going to introduce some additional non-terminals wherever required. Okay, we are going to introduce some additional non-terminals wherever required. Okay, so here you can see. So here this is in Chomsky normal form. So I can directly take TU. Okay, next comes ATV. So here there is a deviation. This needs to be converted to Chomsky normal form. So in order to converting this to Chomsky normal form, what we are going to do is we are going to introduce some additional non-terminals. So where comes the deviation? So here you can see some terminals are combined with, that is here you can see two terminals are combined with one non-terminal, two terminals are combined, right? So these are the deviations. So for considering that deviation, so what we are going to do is we are going to introduce some non-terminals. So where XA, so we are going to introduce three different non-terminals here. So initially we are going to introduce three different non-terminals, XA, XB, XC. So here you can give any of the name, go for any naming convention. Okay, just for simplicity, I'm giving this naming convention. That's it, right? So what I'm going to do is, so wherever A comes, I'm going to replace it with XA. Wherever B comes, I'm replacing it with XB. Wherever C comes, I'm replacing it with XC. Right, so please make a note. I'm going to replace like this only if there is any deviation. Rest of the places it is going to be as H only. So here there is no deviation, right? So I'm going to keep this term as H. Here there is no deviation. I'm going to keep the term as So rest of the productions where I come across deviations, I'm going to replace with the non-terminals. So for replacing, I need to introduce three different non-terminals. Okay, I'm going to introduce three different non-terminals. That is XA derives A, XB derives B, XC derives C. Okay, so what I'm going to do now? So here there is deviation because it is not in this form, right? So what I have to do, A should be replaced with X, A. Next T. Okay, then B should be replaced with X, B. Okay, then next comes is again deviation. So XA, XB. Next again deviation. So that is one terminal combined with a non-terminal. So which is a deviation XC, U. Then there is no deviation. So we can have as such. Okay, so the next there is a deviation. So XA, B, XC. Then next XA, XC. Next XB, W. Next there is no deviation. Okay, so are you clear with this?
Yes, ma'am.
Yes, ma'am.
Please do try with the rest of the productions now. Okay, please do try with the rest of the production. Hope you are writing this right. So T derives what I'll be having.
XA, B, XB,
XB.
or XC, XB,
So T derives
XCU, or C.
C. So please make a note. We are making changes but only when there is deviation, right? T derives XA, B, X, E, or XA, XC, or XB, W, or B. W derives X, B, W, or B. Hope you have written this right. Have you all completed? Others, please. Only two voice I'm hearing. So
Yes.
yes, good. One more voice. Okay, ma'am. Thank you. Okay, so here again, is all the productions in Chomsky normal form now? Say yes or no. Is all the productions are in Chomsky normal form?
Yes, ma'am.
And let me repeat, what is Chomsky normal form?
The V.
Only I should have two non-terminals or only one terminal. Okay, so but yes, you are trying very good. So here you can see there are three non-terminals. If this is okay, okay. So here again three non-terminals. So here again three non-terminals. So here again three non-terminals. Like this it goes on, right? So for that we have to eliminate. Okay. So what we are going to do now is just again a very simple one. Is derives TU, or I'll be taking the first term. Instead of this term, I'll be introducing a new non-term. Okay. Instead of these two, I'll be introducing a new non-term. So X may, let me call this as Y1. Okay. So where I couldn't track. Okay. Y1 derives T XB. Okay. So let me proceed further. Or XA, XB, or XCU, or C, or here again XA. What can I do? So here instead of this, what can I do?
Make y2 as
Yes,
vx.
yes. Y2 is equal to y2 derives vxc, right? Y2 is vxc or xa xc or xbw or b. Similarly, can you please try, ma? So please do try with the rest of the productions. Yes, ma. Yes, let me proceed with the next one. Yes, T derives. Yes, ma. XA, Y, ma.
Yes, ma'am. States
Mm.
y1 or xxb.
Or XA,
xxb.
XB, right? And then
Then
next is
q derives xcu or c.
the problem is I couldn't track here. Okay, U derives.
xcu.
Let me have one things here. Yes.
U is in Chomsky.
If this is in Chomsky normal form, right? And then here you can see here,
Is it
yes, there is a deviation. Yeah. If there is a deviation, so what should I do? That is
that's
XA by
vxc. We already substituted.
Y2, right?
Yes,
Okay, Y2. Yes, it's already there, right? Yes. So Y2 derives VXC. That's it. Are you clear with this? So here you can see now all the productions are in Chomsky normal form. So please make a note, even if you are introducing a new variable here, it will not be a problem, right? So the only constraint, so here we have introduced y1, right? Because it is already defined. Even if you are introducing a new variable and including a production, that will not be an issue at all. So please do make sure that all the productions are in Chomsky normal form, or that is Chomsky normal form. In this is two non-terminals or only one terminal sequence. Hope it is clear to you all, right? Are you clear with this?
Yes, ma'am.
Okay.
Yes,
What
ma'am.
about yes, good. Thank you, ma'am. That's it with it today. In the next class, we can start with Greek-Back's normal form. Let us see one more example, and then we can move on to Greek-Back's normal form, right? Okay, ma'am. That's it with the today's session. So let me download the attendance. If you have any queries, you can please ask, or else you can leave. Thank you.